Right. So in this video, I'm going to describe a sixth order chirp filter. So the amplitude is now not biquadratic, which is like fourth order, but now it's actually sixth order. So I'm going to use the same parameters which I used for the previous video where I was using a fourth order amplitude as a polynomial, and I'm going to show you what difference does it make when I give it 2 more degrees of freedom, and you can decide if the fits are, you can see that the fits are getting a bit better than the fourth order polynomial, but it's not overfitting the data. So let me just start with this example. It starts to fit with the same parameters that I used for the fourth order polynomial, and now it iterates. Now it's iterating to find the optimal set of the parameters which I've given to the amplitude and the frequency in this chirp signal filter, and we'll just wait for it to pop up the final frequency which it finds in this data. Alright, so it found this frequency for this particular fit which it did with these many free parameters. I'm just going to autofit all the files, and then we are going to compare how it compares with our fourth order fit and see how the fits are different, and they are able to capture more details of the data with these 2 extra degrees of freedom in the amplitude. And now after you see this video, you go back to the video where I was doing it with a fourth order polynomial, and you see how this fit, for example, was a bit different, and now how it's a bit better. So it takes a bit of time. Now it fits nicely, but it doesn't overfits anything. And with all of this data, it doesn't know if it's a peak, it's not a peak. It finds the optimal set or optimized set of a curve which fits it all. So now let's go over this again. So this was the last one which it fitted. Now it's done fitting, and here is the fit. You see it nicely fits over these points, ignores some, doesn't do any overfitting, and here it just finds this particular oscillation of the curve. And for one value where this was negative, you may have to reduce the parameters to actually find another set of parameters which are able to give you a better fit for the intensity profile. And just compare these fits with the video before where I was just showing you this for fourth order polynomial to see how each of them actually changed, and especially like this one where it's now a bit better at handling the tail of the distribution. And in the final version of the chirp filter, I would give you these options so that you can choose a second order or a fourth order or a sixth order polynomial for the amplitude, and then you can choose the frequency parameters and see how or which parameters are best for your data, and then you can use that to plot the histogram finally. Alright, yep.